So we're going to move on in the program to the next satellite project. This will be presented by Emanuel Riegelbauer. Emanuel is a master's student writing his thesis in the Cooling Singapore project at the Singapore ETH Center. He holds a bachelor degree in environmental engineering from ETH Zurich and is currently pursuing his master's degree in integrated building systems at ETH. His current research is focused on the study of urban warming and district cooling in Singapore.
Yeah, thank you very much, Gabriel. So yeah, I'm part of the...
Sorry, Emanuel, I think your screen is over Zoom, or is it mine only? No,
do you see
continue.
it?
Sorry.
Okay, all right. Yeah, I'm part of the Cooling Singapore group, and we explore strategies to improve outdoor thermal comfort and also to cool down the city of Singapore. And I will present one of our sub-projects where we explore district cooling systems as a possible measure to mitigate urban warming in Singapore. Urban warming describes the phenomenon of increased temperature and humidity also in the city. And it's compared to a scenario where the area of the city would be completely covered with vegetation. Urban warming is partially caused by anthropogenic heat emissions, for example, from industry, cars, or buildings. And those emissions we can influence and reduce. Here on this map, you see the energy use intensity distribution of buildings in Singapore. And it's based on collected, so metered data. Yeah. A quick insight on the motivation again. In the top right corner, you see a map of the urban heat island effect in Singapore, which shows that at some times, especially during night, you get up to 7 degrees warmer temperatures compared to a all vegetation scenario. And one cause of that, as I said before, is the heat emitted by humans. In Singapore, 12% of total anthropogenic heat is emitted directly at the building site by buildings. The other large heat emitters are industry and also traffic, but we're looking at the buildings. And we explore district cooling as an alternative to common cooling technologies due to its high energy efficiency and the type of heat rejection. So while decentralized cooling, in particular AC split units, emit sensible heat directly into the street canyons, as shown down here, district cooling towers mainly release latent heat, so vapor. In the first step of our project, we define heat emissions from technologies for the entire island, and we use a bottom-up approach. So utilizing the city energy analyst. And based on this first step, we can then assess the potential of district cooling to mitigate urban warming using weather and forecasting modeling, also called WRF modeling. More details on the workflow. So we have a total of 50 districts which we model in Singapore. And those we model in those districts have very specific characteristics in terms of local climate zones and land use. So local climate zone specifies the surface structure of a district and describes the building height and density. The land use is then like the occupancy of the buildings, such as office, retail, and residential. And with the city energy analyst, we can then simulate each district either with a decentralized cooling system or a centralized cooling system, generalize those results by local climate zone and land use, and then scale them up to entire Singapore. And there we intend to model 3 different scenarios. So one would be decentralized cooling, one would be completely district cooling, and one would be kind of moderate, where we implement profitable district cooling systems. And from this, those scenarios are fed into the WRF modeling, which then in the end gives us the difference in urban warming from the different scenarios. And we can compare them. Next slide. First findings so far show that the local climate zone has a quite low impact on the energy use. So it's not a proficient indicator for the anthropogenic heat flux of a district. On the right here, we have a line chart, which shows several different districts of one local climate zone. And you can see they differ by nearly a factor of 10, which shows that local climate zone is not enough to characterize a district. And we also have to look at the use within the district. Yeah, this is so far first findings, and the expected impact of the entire project is in the end that we can give data-driven consultancy to government agencies on cooling technologies for Singapore. So we bring the aspect of urban warming into the decision-making processes of the agencies, and those could then incentivize certain cooling technologies in districts, leading to a reduction of urban warming overall. We aim to quantify the impact of different cooling technologies on urban warming, which has not been looked at in literature so far. So we are contributing to research in a expanding and growing field. And here on the right, you can see a possible ranking of the sample districts, showing the benefit for each single district of implementing district coolings, and that in terms of urban warming mitigation, but also costs and emissions. Yeah, that's what we hope to achieve. That's it so far.
Thank you very much, Emanuel. At the moment, there is no question, but it seems there is a question popping up. So in the meantime, I want to ask the panelists again whether they have a question to Emanuel.
Yeah, I would have one related to linking the CEA on kind of a building scale systems, district scale systems analysis to this larger scale microclimatic modeling. How do you make the link between those two, obviously, and also resolutions?
Mm-hmm. So yeah, exactly. That's where we want to try to generalize the results we get in terms of anthropogenic heat emissions, which equal the building energy demand. But yeah, we generalize them by local climate zone and also the land use. And then through the spatial distribution of those two, which is available. So we have land use and local climate maps for entire Singapore. Through those maps, we scale the results up to the entire Singapore city. Yeah.
But you then take basically the results of the microclimatic simulations as input parameters for CA demand calculation? Is that also the way back and see how that would influence energy demand?
Yeah, so on the mesoscale level, the WRF simulation, this takes in our anthropogenic heat emissions as an input. So we don't do the climatic modeling on the microscale. We just do the energy.
Okay, so you get the energy consumption values, but it's not like feeding back in a sense. Okay, if we would know more about the microclimate, then that energy demand would also change.
No, in that sense, it's not feeding back. Yeah,
okay, thanks.
So there is a question now by Ali from AIT. Are you addressing internalization of the cost of reducing mortality, meaning applying cooling to reduce damage on human health?
Yes, that's a good question. We are not looking at it up to now, but yeah, then from this urban warming mitigation, you could well translate into a negative cost benefit, economic benefit, and yeah, this would definitely be interesting, but it's not scope of this project so far, at least not of my master thesis, which is this project.
Okay, maybe
but it could be looked at in the future for sure. It's very interesting.
maybe a general comment to Ali. You might want to check out the Cooling Singapore project. I think this takes a holistic approach to the urban warming, urban heat island challenge in Singapore, and I think they do have experts looking at these kind of impacts. So there is one more question from Dell. I would like to understand how the impact of energy demand due to climate change in the future would be modeled. Do you consider future city planning data? Will the master plan of the city in the future be used to link the future climate scenarios?
Yes, again, there are, so we are using certain weather data for the time now, which are dated 2016, but they are existing weather data which are prognosis of the weather in 2030, 2050, which very well could be used for such a scenario. Again, due to limitations in our with our resources, with the simulations, we're just looking at the current time. No predictions.
Okay, thank you, Emanuel. I hope this answers your question.